welcome to the second session of our series of mini webinars on respirator fit testing. Today we will get a why and how, so an overview of the systems, of the possibilities, and at the end you will hear about the next sessions. But I can already mention that then we will go into more depth into the different procedures or different systems. So yeah, let's mention a few practical points. So you as audience are automatically muted and your video is out. You can raise your questions in the Q&A feature, and we will, or Adam and Janina will answer them at the end. If there would be not enough time to answer everything, we will take them and reply in writing. The webinar is being recorded. We will put it on the ESF YouTube channel afterwards so that you can use it for future needs, training, and so on. Next, yep. So for those who would not know the European Safety Federation, so we are the representative federation for suppliers of personal protective equipment, mainly focusing on professional use, so not for the sport sector or for the sport or for PPE used in sports. And apart from national organizations, of which you see on the slide the logos, there's also some companies that joined us as a stakeholder or as a cooperative member. With that, and by the way, I'm Henk van Houten, I'm the Secretary General of the European Safety Federation. So today we have two presenters, Janina Sander, who is chairing our working group Respiratory Protection, and who's employed by TSI, and then Adam Marczak, if that's correct, who is a member of our working group Respiratory Protection and who's working for OHD. So Janina, I think I hand over to you now.
Yes, thank you very much. Welcome everyone from my side as well. As Henk already mentioned, I'm sharing the ESF work group Respiratory Protection, which also organized this webinar series. So I would like to just give a short introduction of who we are as working group, who is organizing this webinar. We are a working group with 25 members from 15 different countries, and all of our members are involved in different organizations and committees around respiratory protection. So we do already have a big knowledge on respiratory protection in our group. The work we do as working group is research on RPE and fit testing, so different legislations, qualification schemes existing. So I should just provide people an overview. We also are having awareness campaigns for respiratory protection, and we do provide education on respiratory protection as well as respiratory risks. So this webinar series is the part we provide education on respirator fit testing, and we do have another webinar series running which takes place next week on the education of respiratory risks within the construction sector. So this is the work we as working group doing, and today, as Henk already said, we have the second part on our webinar series on respirator fit testing, and we start with a question on why fit testing. So why should we do fit testing? And Adam will tell us about.
Right. Yes. Thank you, Janina. Thank you very much, and welcome everybody. Great to be here. So yeah, big question. Why do we actually perform fit testing? And from the European perspective, I think it's a complex question, but the answer is that the first and foremost, it is because it's a legal requirement. So across Europe, fit testing is driven by national legislation. So while we are seeing generally in our European landscape a growth of interest, national legislation will always be the key driver for fit testing and fit test interest. United Kingdom, shown here in this teal color, that is a great example of a country that is very mature in its fit testing. So respiratory fit testing, or as they call it, face fit testing, is something that's been there for a long time. And now any worker that has been issued a tight-fitting respirator in the UK will most likely be used to the fact that he has to perform a fit test. More recent development, Italy, very interesting country, had a new legislation come in that strengthened the requirement for fit testing for the general tight-fitting respirators. So in any work environment where you're issued a tight-fitting respirator, you will be required to do a fit test. And then with Sweden, the latest addition to that, 1st of January 2025, actually, we had a fit testing requirement to come in over the general scope of the entire country when it comes to any tight-fitting respirator. This is a very big step for Sweden, which before had a fit testing requirement emphasizing only asbestos work. So if you worked in asbestos, you were recommended or required to perform a fit test, but not in any of the other fields where you are required to wear a respirator. And this actually reflects a wider trend across Europe. So many countries clearly recognize the benefit. They recognize the benefit of the fit test. They recognize what it gives you as for the benefits of the employer's health and also their safety, but they do not always require it across all industries. So instead, the legal requirements are often linked to specific high-risk exposures. For example, in Finland, in France, fit testing is only required by law when working with asbestos. At the same time, in Spain, it is only a requirement in environments where the workers are exposed to respirable crystalline silica. So this creates a certain inconsistency across Europe. In industries, there are requirements, there are best practices, but we have this paradox where in one country, you're required to fit test when you work with asbestos, but if you cross the border to the next country, you're not required to do that fit test for asbestos, but now you are for silica. So this is something that influences fit testing a lot in Europe, the legal requirements, but that's not the only reason to fit test. So are there any other reasons to fit test? Well, in my opinion, there are many. We mentioned for the employer, it starts with the legal requirements. They must ensure in those countries where this legal requirement is present that the PPE fits properly and that the workers are trained to use that PPE. Fit testing supports both, right? Fit testing is not just taking a machine and doing a test. It is a process of getting to know the respirator, getting familiar with it, and training on how to use it. The fit test is the final step. But fit testing supports the fact that it will fit you properly and you will know how to use it. Then for the employee, there are questions as the safety. Right now you can be issued the best possible respirator out there, but if it doesn't fit you, it will just create a false sense of security, and you will not all actually feel that it's providing you, or it will actually not provide you with anything positive for your health. But then there are also comfort and training. Over and over again, when we're out doing fit testing, we can see that often people will have the struggle when they redeploy a respirator after a break or so on, and they do that incorrectly. So training is very, very important for that employee so that he feels safe and educated on the respirator that he's using. And all of that will lead to comfort, will promote the fact that you are wearing your PPE properly. So if we go to the next slide, what is the point of fit testing? What does it actually do? Because we haven't really talked about that yet. So just super quick here. This is great for any employers watching that face opposition when trying to talk fit testing in your workplace. So think of the assigned protection factor. Assigned protection factor is sort of as a performance factor for the respirator. It is essentially telling us how much protection a respirator can provide when used properly and correctly. So when it fits you in the workplace, right? It's the value that is used to define whether a respirator selected will be suitable or not for workplace exposure. So if we take a step back, how do we know when we actually need to wear a respirator in the workplace? Well, that includes a risk analysis. That risk analysis is often connected to doing air sampling. So you take a pump, you measure against a certain contaminant that you know you have on site, and then you get this very exact workplace concentration of that given contaminant. You can then check whether you're below or above your occupational exposure limit. If you're above your occupational exposure limit, you must make sure to lower it. All right. How do we lower it? For different things, but one thing is respiratory protection equipment. Taking on a respirator with an assigned protection factor, you do the math. If your workplace concentration is 100 ppm and you're allowed to only have 20, well, then you need an assigned protection factor of 5 or greater. But the assigned protection factor is just a value given to that respirator. It's like a max velocity of a car. But if you don't use that car properly, you're not going to get that max velocity, right? So we have a different factor called the workplace protection factor, which is an in situ measurement. It's actually on-site measurement within the breathing zone of the respirator and outside. And that gives us a value that's kind of the true protection value in that very minute with that respirator. And research has been done on that. So for example, in the study that we can see on this slide, we had a lot of people that were fit tested and a lot of people that were not fit tested go out on site, perform their daily tasks with a respirator on them while performing workplace protection factor measurements. And the results were staggering. It was incredible. If you had performed a fit test before and you made sure that the respirator that you were wearing, the respirator that you were fitted with, and the respirator that we confirmed that would fit you, you had a 85% chance to obtain the assigned protection factor. The same workers that were on the same site that did not get fit tested had a 5% chance of getting that protection. So again, using that analogy of a car, with fit testing, to get to the maximum velocity of the car, you had an 85% chance. Without, a 5% chance. Massive. And we see that in more and more research. For example, on this next slide, there was research done on FFPs, so filtering phase pieces. And you can again see that an FFP with and after a fit test provided a protection factor that was very high, very good, 20 times what you would expect. But an N95 without fit test, so an FFP without fit test, provided almost more or less the same protection as a medical mask. We all know medical masks from COVID. They are not there to protect you. They're to protect the people around you. So why do we fit test? Well, because it will increase dramatically the chances of you to obtain a good protection with your respirator. So that is the why here. And now I suppose, Janina, over to you on the how.
Yeah, thank you very much, Adam. It was impressive graphics there showing us the why fit test is important. But if you now understood why, we are interested in how we can do a fit test. And there were in general 2 different methods. And the first method is qualitative fit testing. So quite quick here, you wear your respirator, you are exposed to a test substance within a local test atmosphere. This test substance is bitter or sweet tasting or smelling, and you do need a subjective evaluation if you sensory recognize this test substance or not. So the idea is here that if the mask fits you properly, you can't recognize this test substance, you can't taste it, you can't smell it, while if there are leakages, so the mask is not fitting you properly, you can taste this test substance. And how this looks, you can see on the picture. So you're wearing the mask, and what you clearly see on the pictures is that this qualitative fit testing method is for half-phase respirators, FFPs, as well as elastomeric half phases. You have this hood, and there's the operator spraying you this test substance into the hood, and then you need to see if you test it or not. And in general, there are different sub-methods available. You can taste an aerosol called Bitrex, which is bitter tasting. You have saccharin, which would be sweet tasting. There is the chance of also having a vapor to smell, which is called isoamyl acetate, or also banana oil, because it's smelling like bananas. And there's the third sub-method in qualitative fit testing called irritating chemicals, irritant smoke. What is important here is that this is not a globally accepted method to do qualitative fit test, because as it says, it's irritating you. So there's a health influence by this chemical, and the US OSHA protocol accepts this method as the only protocol globally, but on the same side, the NIOSH in US recommends against it. We just wanted to list it here for the full picture. And yeah, as I already mentioned, and you could see on the pictures, qualitative fit testing is only allowed for disposable and reusable half masks, not for full face masks. And that is equal to a required minimum fit factor of smaller or equal than 100. On the other hand, you have the quantitative fit testing. Quantitative, as you do have a measurement instrument that is performing a measurement and gives out a number, the fit factor as a number. And there are two methods available within the quantitative fit testing. One is the so-called CNC or APC method. CNC stands for condensation nuclei counting, and in the UK it's the same method but called APC ambient particle counting. And there in this method you have a particle counting outside the respirator and inside the respirator, so quite similar to what Adam explained us about the workplace factor, protection factor measurement, just so that you do it here in the fit test. And you determine the concentrations inside versus outside, compare them, and the ratio is the fit factor. The other quantitative method is the CNP method, which is the controlled negative pressure, which is somehow a flow measurement. Why flow measurement when it's called negative pressure? Because it's measuring if the constant negative pressure inside the mask is stable in case of there are no leakages. It's expected to stay there when you're not breathing, while if there is a leakage, you cannot hold the negative pressure because there's an airflow coming into the mask. As I already mentioned, there are some limitations, especially for the qualitative fit testing, and this is what you do see here in this table. It is important when you perform fit testing to select the right method. Qualitative fit testing can be used for filtering face pieces as well as quarter face masks or half face masks. I know that quarter face masks are in the real world not really much used. I personally never saw one in the real world industry application, but as they exist on paper, we wanted to mention them here in full. So everything up to a half face mask can be tested with qualitative fit testing. Full face masks cannot be tested. The quantitative fit testing method CNC can be in generally used for all types of respirators, so filtering face pieces, as well as all types of reusable respirators, including full face masks. But for testing FFP1s and FFP2s, you do need a special technologies like an advanced instrument to be able to test this lower category of filters. FFP3 onwards can be tested with every type of CNC machine. Last but not least, the quantitative method, controlled negative pressure. This can be used for all reusable respirators, as of course with filtering face pieces, the whole mask is a filter. You will have an airflow going through. With reusable respirators, you can use this method here. So also full face respirators are covered by that. And yeah, just you might still have lots of questions about what exactly is qualitative, what exactly is CNC, what is CNP method. I just gave a very quick overview because our next 3 sessions of mini webinar series will exactly cover that. We'll have one on qualitative fit testing, one on the CNC method, and a third one on the CNP method. So you will learn every details in the upcoming webinar series. There's one other thing next to the methods, and that's the protocols and procedures, which are important for the how-to question, and Adam will tell us about.
Absolutely. Thank you, Janina. Yeah, so as Janina mentioned, we have different methods and we have different protocols. So this is, I think, very interesting to know and something to also take, I don't know, some security safety in that. Fit testing, while on paper can seem a little bit complicated, it is very well defined. There are protocols in place, there are frameworks in place, there's a lot of educational information out there. So, as we mentioned, UK being on the forefront in Europe, a country that definitely has had a general legislation for fit testing for the longest. In the UK, we use what we call the HSE protocol. INDG 479 is a document that is publicly available that you can find and read online to understand better how to perform a fit test in the UK. What is going to be maybe educational here to say is that the HSE protocol, it will be different for the different type of method you use, right? So as Janina mentioned, we have the qualitative method, then that's going to have certain requirements and certain steps for the qualitative method. Then you will have the CNC method, then you will have the CNP method. So this is something that is very important to know, because in different countries, in different regions, you'll have different protocols. In the US, we have OSHA, and OSHA defines a certain way of testing, a testing framework there. In Europe, we have HSE for the UK, but we have ISO for most of our other countries. For example, Italy also uses ISO standards, but with some inspirations from HSE. It might all sound very complicated and complex, which is again take safety, knowing that we will hold more of these sessions to talk about how these tests are done. But in order to perform a fit test, you need to have the right methodology matched with the correct protocol. This is the main takeaway here. And in this next slide, if we could go there, we can see how these fit test exercises can vary. So on the very right, you have OSHA, right? And you can see the different test steps that you are required to do with the OSHA protocol. There is the standard protocol and something called the OSHA Fast Fit, which is why there are 2 here for CNC, for example, listed. Then we have the ISO protocol. The ISO protocol will have one methodology for CNC requiring you to perform 7 steps, and for CNP it will only have 5 steps. And HSE just does the same essentially sequence when it comes to the protocol for all of the different technologies. So depending on which protocol you're using and which methodology you have deployed, you will sometimes have variations when you perform this fit test. And then finally, the next slide, if we would jump there, what do we do with the results? Well, in qualitative testing, essentially, as it is mentioned, it is a subjective test. Did you smell the substance that you were exposed to? Did you taste the substance you were exposed to? No? Well, you passed your fit test. Yes, well, then you have a list of items that you have to go through to find a fit that fits you. In quantitative fit testing, it's objective. We do not need to get the output from the person on the test directly. There is a mathematical equation to get an overall fit factor that needs to be above a certain level, which is also something that is connected to different protocols. A protocol in the UK will have different requirements than a protocol in, for example, Sweden for the ISO and HSE standard for certain methods. Again, a lot of confusion here, a lot of things to cover. Do not worry, more of these mini webinars will come and we will continue to go through this section. So over to you, Janina.
I should unmute myself. Yeah, what you just see on the slide is the different required minimum fit factors. As Adam said, we don't want to go into much detail, but it is there for you to read through afterwards in the presentation. Because next to the protocols, there's one thing missing, and this is when to perform fit tests. And in generally, it is needed the first time you use a respirator. You should fit test before. You also need to fit test when there is a modification of the respirator, if there's a change from the manufacturer, or if you change the model, if you change the class of the respirator, whatever it is, you then need to do a fit test as is seen as a new respirator. You also need to perform fit test if the comfort is not satisfactory or if the wearer mentions that he feels uncomfortable with it. Then the next point when you need to do fit testing is if there is a physical change in the wearer. For example, weight loss, because this also changes our face, and this is where the mask needs to fit. If you have scars, if you have big dental work, etc. So everything that influences the shape of our face is a physical change, and therefore we need to redo fit testing. And last but not least, we should also do a periodic retesting. The exact requirement here is again depending on the protocol. And in generally, we would say it's highly recommended to redo fit tests every year. Like in the OSHA protocol, it is required to do it every year. In other countries, it's recommended to do it every 2 years. But in general, however it looks like in detail, there should be a periodic retesting just to cover all the changes. And last but not least, let's take a look at the quantitative fit testing. Here is an example, the steps that need to be done expect of the exercises. Of course, you always need to have some general preparation if you do a fit test. Then the person arrives, you need to check if the person is suitable. So for example, clean shaven, as you need to be clean shaven when wearing tight fitting respirators. You need to check the respiratory selection. You need to install possible fit test adapters in quantitative fit testing. Then the person needs to correctly don the respirator, should perform the wearer seal check, or also called fit check. Then you need to assess the comfort and if it's tight fitting, giving some last instructions to the fit test before then finally you perform the fit test with the exercises that Adam described. And with that, this was our overview, very quick overview about why and how to perform fit tests. And as announced, we will have on May 22, again at 11 a.m. Central European time or Central European Summer Time, it is in May, a webinar about qualitative fit testing. So you will get the details about the process of qualitative fit testing, the important considerations to make, and therefore we do have an external speaker from Medicom who are manufacturers of qualitative fit test equipment. And if you're interested in, you directly have the link here and the QR code for registration. And in July, we will have our webinar on the CNC method. So what is it exactly? How does the method work? How do you use this method for fit testing? And there will be more to follow in September and November to cover CNP and also the rest. And with that, we are done with our half an hour, but of course, welcome your questions. I do see one in the Q&A. already, which is why no qualitative fit test with full face masks. And I think Adam explained it quite well when he talked about the different procedures, because qualitative is subjective, while quantitative is an objective measurement. And full face masks do have a very high assigned protection factor, because this is the ones that really can protect us if there's lots of hazard, and therefore you should test the fit as objective as possible. Adam, do you want to add something?
No, yeah, I think that was excellent. I think we did not bring up the word fit factor too much. Fit factor is essentially the level of how well respirator fits you. We talked about the table that Janina showed, which fit factor you're required to have, and generally a qualitative fit test gives you a fit factor of 100, not less, not more, if you pass it, yeah, and you never need only 100 for a full face mask, a full face respirator, which is also why you cannot pass a fit test with a full face respirator using a qualitative test, but exactly for the reason that Janina mentioned here. So I feel that was a very good response.
Okay, thank you. Looking at the time, and I don't see any further questions. There was one question in the chat asking for the link for the registration. I did put that in the chat, by the way, so you can see it there. Otherwise, if you go to, I don't know if you have a next slide, Janina, to close, but otherwise, if you go to our website, eu-esf.org, and you click on events, you will see there the upcoming webinars and with the link to registration and so on.
And you will get the presentation after this webinar as as registered people, and we will also include the link there, right, Hank?
Yes, indeed. So with that, I think we can conclude, even if we are a few minutes late. So message to the next speakers, or a hint to the next speakers. But I know it's a lot to cover in half an hour, but so you did a good job trying to cover a lot. But I would say definitely follow the next webinar sessions as well for more details on the different methods and procedures. And with that, I think we can conclude for today. So I can only wish you a nice weekend.
Thank you very much.
Thank you. Bye-bye.
Goodbye, everybody.